tangent ratio. A third trigonometric ratio is tangent. Tangent in a right triangle is the ratio of the length of the opposite side over the length of the adjacent side. So tangent of x is equal to length of the opposite over the length of the adjacent. So let's have a look at our two pictures here below. In this first picture, the tangent of angle A. So first of all, find angle A. And the tangent is the opposite side over the adjacent. The opposite side of angle A is the one that's the furthest away. So here's our opposite side over the adjacent. And so it's going to be side A over side B. Remember though that those opposite and adjacent sides change depending on what angle you're looking at. So in the second picture, we're asked for the tangent of angle B. Angle B is down here. That means that my opposite side is now over here. And so the tangent of angle B is the opposite side, or side B, over the adjacent side, side A. Let's look at some numerical examples. So we're asked to find side x. So always start by labeling your triangle. This is the angle that we're given. Here's our 90-degree angle. Our hypotenuse would be up here. This side would be opposite of the 19 degrees, and this side would be our adjacent. Our hypotenuse in this question doesn't help us. It's not the side that we're given, and it's not the side that we're looking for. So we're looking for the opposite, we're given the adjacent side. That means that we're going to use the tangent function. The tangent of any angle is equal to the opposite side divided by the adjacent side. So in this question, the angle that we have is 19. The opposite side is x, and the adjacent side has a length of 8. To solve, we're going to get x by itself by multiplying both sides by 8. And so we end up with 8 times the tangent of 19 equals x. Remember that tangent of 19 is just a decimal number that our calculator can give us. And so we end up with 8 times that decimal number, works out to be 0.3443. So 8 times that decimal number will be 2.75 is the length of side x. Example number 2, I'm just going to try and move our picture down a little bit so we have some more room. In example number 2, we're asked to find, again, a missing side. So start by labeling your triangle. If this is my angle, this is the opposite side and the adjacent. So because we're using opposite and adjacent, again, that means that we are using the tangent function. The tangent of any angle, and our angle this time is 75, is the opposite side, which is 19, over the adjacent side, which is x. We now need to solve for side x. So we could think of it as cross-multiplying. If we do that, we multiply this way. So we end up with x times the tangent of 75 equals 1 times 19 is 19. To get the x by itself, we want to divide by the tangent of 75. Remember, tan 75 is one thing, it's a decimal. We have to divide both sides. On the left-hand side, the tan of 75 will cross off, just leaving me with x. And on the right-hand side, we have 19 divided by the tan of 75. So it's 19 divided by, let's change that tan 75 now to a decimal. As a decimal, it's 3.73. And so we end up with x being equal to 5.1. Our next question is a word problem. Gull Harbor Lighthouse is located on Manitoba's Lake Winnipeg. Assume the lighthouse is 14.6 meters tall and stands 7 meters above the surface of the lake. If the angle of depression to a boat on Lake Winnipeg is measured at 27 degrees, approximately how far away from the base of the lighthouse is the boat? So we're looking for this distance from the center of the bottom of the lighthouse to the boat. So that's side X. We're told that the angle of depression is 27 degrees. Angle of depression is if you were standing in the lighthouse looking out, that's the angle going down towards the boat. Remember that that angle of depression there is equal to the angle of elevation if you were standing in the boat looking to the top of the lighthouse. We have the total height to the top of the lighthouse being this complete distance. That distance is made up of the 14.6 meters from the lighthouse plus the 7 meters to the top of the hill, or from the water to the top of the hill. So adding those two together gives us a side length over here of 21.6 meters. If I redraw our triangle, it might be a little easier to see. So we have an angle in here of 27. We're looking for this distance to the boat, and this side is 21.6. For this angle, this is our opposite side and our adjacent side. So again, we're going to use tangent. So the tangent of 27 is equal to the opposite side, or 21.6, divided by the adjacent side, which is x. Solving for x, we can cross multiply. So we end up with x times the tangent of 27 equals 21.6. To get x by itself, we need to divide by that tangent 27, which again is just a decimal number. And we end up with x equals 21.6 divided by the tan of 27, and the tangent of 27 is 0.5095. Dividing those two numbers out gives us a total distance of 42.4 meters from the lighthouse to the boat. Our last example, a dock worker pulls a light crate measuring 2 meters by 2 meters by 2 meters up to the dock using a pulley system. The angle of elevation of the rope is 50 degrees. The man is 2 meters from the edge of the pier, and the bundle clears the pier by 0.5 meters. How close are the pulleys to each other when the bottom pulley is at hand level? Okay, so the distance between the two pulleys, they've labeled here as h. So this is what we're looking for. If we're going to use the tangent function, means that we need to find the total distance from the man to this pulley. Well, the first distance is the 2 meters that he's standing back from the dock, plus the 0.5 meters that's in between the edge of the pier and the crate. And then that pulley is located halfway through the crate, so we need to add 1 more meter. Gives us a total distance there of 3.5 meters. So if we redraw that triangle, we have an angle of elevation of 50. This side is 3.5, and we're looking for the height. Again, we're going to use tangent. So the tangent of our angle, so tan 50, is equal to the opposite side, which is h, divided by the adjacent side, which is 3.5. Again, we can use cross multiplication to solve. So we have 3.5 times the tangent of 50 is going to equal side h. This is 3.5 times the tangent of 50 is 1.1918. Multiplying those two out gives me 4.17 being equal to side h. And if we round that, we end up with the distance between the pulleys being 4.2 meters.